Good day, everyone. Today I will be discussing all about limits of a function. So, what is a limit? Limit is a value that a function or sequence approaches as the input or index approaches some value. Limits are essential to calculus and mathematical analysis and are used to define continuity, derivatives, and integrals. Did you know that, by definition, limits of a function is a fundamental concept in calculus and analysis concerning the behavior of that function near a particular input? And it is also used to determine the possible location of a moving object as they approach a certain place or location. So there are three ways to approach in finding limits. 1. Numerical approach or t-table. 2. Graphical approach or analyzing the graph. 3. Analytical approach or using algebra or calculus. So rewrite this symbol and say the limit of f of x as x approaches a equals L. So if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a but not equal to a. So this says that as x gets closer and closer to the number a, the values of f of x gets closer and closer to the number L. So in finding the limit of f of x as x approaches, we never consider x equals a. In fact, f of x need not even be defined when x equals a. The only thing that matters is how f of x is defined near a. So we have here some definition of limit theorem. So as x approaches c, the limit of f of x is L. So if the limit from left exists and the limit from the right exists and both limits are L, that basically defines a limit theorem. So there are following techniques in finding limits of a function. So first technique is direct substitution property. So it can be used if f is a polynomial or a rational function and a is the domain of f. So then limit of f of x as x approaches a equals f of a. So for example, letter A, limit of 2x squared minus 3x plus 4 as x approaches to 5. So we only simply substitute the value of x, which is 5. So that will give us the answer, which is equal to 39. Second example, limit of x cubed plus 2x squared minus 1 all over 5 minus 3x as x approaches to negative 2. So in this example, we only simply substitute the value of x, which is negative 2, and this will give us the answer of negative 1 over 11. Take note that functions with direct substitution property are called continuous at a. However, not all limits can be evaluated by direct substitution. So factoring and cancelling is another technique that can be used in finding limits of a function. So for example, finding the limit of x squared minus 1 over x minus 1 as x approaches to 1. So we cannot find the limit by substitution process or by simply substituting x equals 1, because 1 squared minus 1 is equal to 0 and 1 minus 1 is equal to 0, and this will give us 0, which is undefined. Instead, we need to do some preliminary algebra. We factor the numerator as a difference of squares and then cancel out a common term, which is x minus 1. So therefore, limit of x squared minus 1 over x minus 1 as x approaches 1 is equal to limit of x minus 1 times the quantity x plus 1 over x minus 1 is equal to limit of x plus 1 as x approaches to 1 is equal to 2. So take note again that in that example, we were able to compute the limit by replacing the function f of x is equal to x squared minus 1 over x minus 1 by a simpler function g of x equals x plus 1 with the same limit. So this is valid because f of x equals g of x except when x is equal to 1. So another technique that can be used in finding limits of a function or limits of a function is if there are fractions within fractions, we need to try to combine the fractions. So for example, find the limit of 1 over 4 plus 1 over x all over 4 plus 1 as x approaches to negative 4. So we cannot use the substitution method because the numerator and the denominator would be 0 if we will be trying to use the substitution process. So we will be using this technique. So limit of 1 over 4 minus 1 over x all over 4 plus x as x approaches to negative 4 is equal to limit of x over 4x plus 4 over 4x all over 4 plus x as x approaches to negative 4 is equal to limit of x plus 4 over 4x all over 4 plus x as x approaches to negative 4 is equal to limit of x plus 4 over 4x times 1 over x plus 4 as x approaches to negative 4 is equal to limit of 1 over 4x as x approaches negative 4. That will give us the answer which is equal to negative 1 over 16. So another technique to be used is if there is a square root, we need to try to multiply by the conjugate. So take for example, in finding the limit of square root of x squared plus 9 minus 3 all over x squared as x approaches 0. So here, we cannot use the substitution method because the numerator and the denominator would be 0. So that will give us undefined. So limit of square root of x squared plus 9 minus 3 all over x squared as x approaches 0 is equal to limit of square root of x squared plus 9 minus 3 all over x squared times the quantity of the square root of x squared plus 9 plus 3 over the quantity of square root of x squared plus 9 plus 3 is equal to the limit of the quantity of the square root of x squared plus 9 squared minus 3 squared all over x squared times the quantity of square root of x squared plus 9 plus 3 as x approaches to 0 is equal to limit of x squared plus 9 minus 9 all over x squared times the quantity of a square root of x squared plus 9 plus 3 as x approaches to 0 is equal to limit of x squared all over x squared times the quantity of square root of x squared plus 3 plus 9 as x approaches to 0 is equal to limit of 1 all over the quantity of square root of x squared plus 9 plus 3 as x approaches to 0 is equal to 1 over the quantity of square root of 9 plus 3 is equal to 1 over 3 plus 3. That will give us the answer which is 1 over 6 or 1/6. So real life limits are used anytime we have some type of real world application approach as steady state solution. So limits really can be applied in real life. Everything has a limit in this world we live in, and that is the reality. Some of us are just unaware of it. So, some examples of real life application of limits are speed limit, vehicle capacity, limit of food we eat, limit of using the internet, and limit of amount of medicine we intake. So let's try evaluating limits and how they are used in one of the basic problems of calculus, which is the area problem. So take for example, finding a maximum area of a rectangle. So given a scenario or a situation that Josh is given 36 inches of wire and is asked to form a rectangle whose area is as large as possible. So the question is, what dimension should a rectangle have? So our solution, we will be taking step-by-step process so we can get our answer. So step 1, let W represent the width of the rectangle and let L represent the length of the rectangle. So let 36 be the perimeter. So the formula of a perimeter of a rectangle is 2W plus 2L equals 36. So next step is to find for the length or the L. So in finding the length, 2L is equal to 36 minus 2W. That will give us, so transpose rather. So transpose, L is equal to 18W. So you divide both sides by 2, that will give us length equals 18 minus W. So step 3, find the area of a rectangle. So the area of a rectangle is equal to length times width. So equal to 18 minus W times W. So this will give us 18W minus W squared. So step 4, we need to locate the width and length on the rectangle. So locate the length and the width. So the width is the line that is horizontal and the length is the vertical line. So opposite rather. The width is the vertical line and the length is the horizontal line. So step 5, we need to use table to experiment with different values of width to see how to obtain the maximum area. So we try 7.5. The area is 78.75. When we have a width of 8, this will give us 81. Width of 8.5, this will give us 80.75. Width of 9, this will give us 81. So this is the maximum area. So 9 is the maximum area among all of the given table of experiments. So next is find for the width that has a maximum value of an area shown in a table. So thus 9W has a maximum area which is 81. So that is the limit of a function. So last step, write down the limit. So limit of A as x approaches to 9 is equal to limit of A 18W minus W squared is equal to 81 as x approaches to 9. So this example shows that the limit of a maximum area of the 36 inches of wire in forming a rectangle out of it. So the maximum area, as I've said, is 8 width. So these are the references I've used in preparing this presentation. That would be all. Thank you for listening and God bless. Happy learning!